Okay, in today's video, we're going to look at how to solve, well, it's basically solving equations simultaneously, but it's kind of, it's asked in a way, let's say they'll say, hey, there's a graph and there's a straight line, and you have to find out where they actually cross. So it's basically simultaneous equations, and you can just do it algebraically, but we're going to look in a little bit detail. We're going to start off with a really easy one at what we're doing. And yes, you can do it without even thinking about graphs. You'll just sub in x and you'll solve, you'll sub in x in the place of y and you'll solve it and etc. But I just want to go through the motions of what's actually happening here. So in this case, we have a quadratic equation. So that would be a parabola. It's a positive parabola, so it's going to look like this. And in this case, we have a line. Now, we know that line is a very special line. It's just a diagonal line, y is equal to x. And there's two places where this line cross. And there's a way for us to find the x coordinates. So what I do know is at these 2 points, the x values and the y values for both of these are going to be the same. So for this graph at that point, x and value is the same as for the blue graph, and for the red line and the blue line, both of the x and y values are the same here. So this is a very simple example, but let's just go through the motion. So what you would do is you would write these lines or these graphs in kind of standard form, where y is the subject and the rest is going on. Now, if it's not as y, this can be given a different way. They could write it in function notation, like f of x is x squared minus 2, and f of, well, there wouldn't be f of x, it would be something else, so they'll be calling it maybe g of x is equal to x. So it's, you can see the y is just replaced with this f of x kind of notation, and they'd say there's a curve and a curve and a line, and they cross somewhere, and you have to find out where they cross. Now, your first step would be to just write whatever is on the one side and equal it to the other graph. So you'll equal them or equate them to each other. So in this case, you'll write x squared minus 2 is equal to x. So because y is equal to this and y is equal to this, and I know both of the y values are going to be equal for both graphs at that point, I just equal them to each other. So in this case, I would take the x. Okay, so I'll solve it. This is a quadratic equation, so I'll put everything over to one side. And this is a very important step. So you have to, you're going to have to think about this in steps. So step 1 is going to be put the one equation, this is my curve, and equal it to my line. The second step is moving the curve and the line, everything together to one side, because that's usually what I do with a quadratic equation, is I put everything on one side. So it's x squared minus x minus 2, and then I would solve this, and I'd find, usually I'll find two x values. So x and x, and it's going to be 1 and 2. And in this case, it's going to be negative 2 and plus 1. So my answers would be x is negative 1 and x is 2. So what does this mean? I'm getting two x answers. What is this? Well, this is the two x values for where these two lines cross. So this line has an x value, because this is my x. Let's say x is going, obviously this side is negative and that's positive for the x-intercept or the x-axis. I know the negative x is going to be on this side. So here the x value is going to be negative 1. And this is on the more positive side, so that's going to be 2. So now what I've done is I've put these lines and I equaled them to each other. I put everything on one side, and I found x's as answers. And then from here, I would put in this negative 1. I'll put in either of these. Now this one is the easiest one, because it's, if x is negative 1, y is negative 1. So that's very simple. And for x is 2, I'll do the same and I'll get this. So this was a very easy example just to show what we're doing. Again, equal them to each other, put everything on one side, find the x values, and then sub in the x values. Let's say if something, there is maybe one or two chances, or not say one or two chances, I'm just saying that it might happen that you only get one answer here. Maybe you get something like x plus 1, x plus 1 as an answer. So what that would mean is that the curve and the line are only touching because there's only one point, there's only one answer. If we didn't get an answer, if this was not factorizable and we put it in the quadratic formula and there was no solutions, it would mean that the line and the graph, they don't touch each other, and they would never touch each other. I don't see this too often in IG level, but it's good to be aware of this. But let's do a more tricky example of this. And let me just rub all of this out, and you should be able to do this on your own without me. So if once you see the examples, maybe you can try and do them on your own. So I'm going to write the first one. It's 2x plus y is equal to 6. And the other one I'll do in a different color. Y minus x squared is negative 2. And the question they're asking us here is saying, hey, there's a line and a graph. Find the points where they intersect, or where do they cross. And you can pause the video now and try and figure it out on your own. But the first thing that I notice here is it's not in kind of their normal standard forms. So for both of these, I'll make y the subject. It'll just make it a little bit easier for me. So y is going to be negative 2x plus 6. And in this case, I'm going to have y. Let's do that in blue as well. Just keep the colors the same. Y is equal to x squared. No, is that it? Is that okay? It doesn't seem too difficult. Oh well, anyway, they are a little bit different. Hopefully this works out. So which one is the line and which is the graph? Well, the black one is the line because it is a linear function, and this one is a curve. Well, both of graphs, right? So, but this one is a line and this one is a curve. So what I can expect is that there's going to be a blue parabola maybe doing something like this, and there's going to be a black line. This one is a negative, so it would have a slope like this. So I'm kind of expecting something in that way. So what I would do is the step one is I know at these 2 points the y values are the same, so I'll just put this function equal to that function. So very straightforward. Let me get this color. Let's do negative 2x plus 6. Do a little bit of color coding. And x squared minus 2. Now this is a quadratic equation. It's kind of a new equation that was formed by a line, let's say a line, straight line, and a parabola. But in order to solve this, I'm going to have to put everything on one side and equal it to 0. So let's put everything on that side. I'll put 0 on this side. We're going to have x squared. This is going to be plus 2x, and that's going to be minus 6. I'm taking 6 off on both sides, so that's minus 8. And hopefully this would factorize, otherwise I'll have to complete the square or do the quadratic formula. I'm just running into this. I'm thinking 2 and 4 should work. And if I have a plus 4 and a negative 2, that would work. And I'm going to get 2 answers. So x is going to be 2 and x is going to be negative 4. So if I look at my little rough draft drawing here, that place over there, the x value is going to be negative 4. And that one over there, the x value is going to be 2. And I would expect that the y value for this one is going to be a bigger number than the y value for that one, like just thinking about the graph and how it's set. But in order to find the y answers or the y values, I'll have to put the x-intercepts in either of these functions. Now, this one, it seems that it's going to be the quicker one, negative 4. So negative 4 times negative 4 is 16. And then minus 2 is going to be 14. So that makes sense. And 2 times 2, if I had to put the 2 in there, the 2 I got from here, 2 times 2 is 4, minus 2 is 2. So in this case, yeah, it does make sense. The -1 is on this side, positive there. Y value was a little bit bigger because it's higher up because the gradient is a negative gradient in this case for the straight line. But yes, so in the next video, I'm going to look at an example where they give you, and this is now the tricky part. They're going to give you this equation and maybe this equation, and they're going to ask you this line. So kind of just think about that. We're going to be given this combined one, and then we should get this one. Maybe I should just do that now because maybe people can't find the next video. So let's just do this now. So just think about what I'm saying, or let's use this example. Yeah, let's quickly use this example. Let's say they did not give us this. I'm going to wipe this. Okay, let me just write it here as proof. 2x plus y is 6. Sorry, this is becoming a very long-winded video, but yeah, I mean, this is usually a very, very tricky question to ask. So let's wipe this off and wipe that off. Okay, there we go. And I'm going to, yeah, let's just erase everything. Okay. So the question might read, they say, oh, let me just find wording for this type of question. Sorry, I just want to get something over here. Goodness me. Sorry, bear with me. Just want to quickly get the wording for a type of question. So they might say, the curve, this, is drawn on a grid. And then they say a line is drawn on the same grid. The points of intersection of the line and the curve are used to solve this equation. Find the equation of the line. What? So basically they're saying, hey, there's a graph. There's a line crossing the graph. In order to solve that equation, this is the equation. If we have this equation, then you can get the line. So the question is, how did we get this equation? Well, we got this equation. If you remember previously, we had a line and a curve, and we equaled them to each other. And but that became a quadratic equation, and in order to solve it, I had to put everything on the one side. Sorry, this is very visual, but then I would have combined these two. Obviously, this would have been now negative, and then that would be equal to 0. And this is what we have here. We have a function that's combined. This has a parabola inside and a straight line inside, but they only gave me the parabola. So, okay, let's just make life easier and rearrange this. Y is x squared, there's a little 2 left, x squared minus 2. So basically I know this x squared minus 2 is hidden in here, and it's combined with a line. And those like terms were added together and I got this thing. So in order to get it out, what I usually do is I'll write the line that they gave me from the start. So I'm going to write this line. I just want to check if I have enough space. Sorry about that. So what I'm going to do is I'm going to write my x squared minus 2. And then I'm going to compare it. So this x squared, I have an x squared there, and I have one x squared here, so that's fine. Nothing happened with the x squared parts. What I have here is a plus 2x, and that's new. There's no something with an x here, so I'm going to add it. Let me just put it in a different color. Let's do it in this color. So I'm plussing 2x because I know, you know, these two things were equal to each other, they were then combined, but suddenly there's a 2x here, and it's not coming from this function, so that must have come from the other function. And here I have a negative 8. but I only have a negative 2 here. So in order to get a negative 2 to a negative 8, I actually have to subtract another 6. So basically, I'm checking x squared, yes, check. Negative 2, I have, check. But there's a negative, well, sorry, there's a plus 2x here. So, okay, good. I got that one. And there's a negative 8, which I would get by this and this. So basically now I have my curve and I have my line, and I'll put this all equal to 0. And then what I'm going to do is I'm just going to move the line back over so that on this side I'm left with x squared minus 2. And on the other side, I'm going to be left with minus 2x plus 6. And this now is the line that we're looking for. So I can write it as y is equal to negative 2x plus 6. And if we rearrange this, it's going to be y is negative 2x plus 6. So yeah, I know that was probably a little bit tricky to visualize. I'm going to make a video in the next one where I do an example like this from a past paper question, and then you can see like exactly how it's done and how you can kind of navigate it and figure out how to solve it.